Alright, so this video is going to be part 3 of our parametric and polar review. Alright, this video specifically will be talking about graphing parametric and polar. So, x equals t squared, y equals t. These are the parametric equations that we want to graph right now. So, how do we graph these? Well, we use that txy chart. Okay, we have our t's, our x's, and our y's. Alright, we draw our little chart here. And let's graph it from -3 to 3. All right, so we'll have a -3, -2, -1, 0, 1, 2, 3. Of course, y equals t. All right, I wasn't going to make this too hard, all right, because just going through the process is enough. Okay, so you get your -3 through 3 here, and x equals t squared. So we can just say, okay, well, this is going to equal, x is going to equal this squared. It's going to be 9, 4, 1, 0, 1, 4, 9. All right, so you kind of already start to see what we're going to get here. Okay, we end up with, well, let's start plotting. Well, we have a y of -3 and an x of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have a -2. Well, we have a 4 comma -2. 1, 2, 3, 4, down 2. We have a 1 comma -1. It's going to be right here. A 0, 0, a 1, 1. And then we have just basically it's going to be mirrored on this side. All right, we can just connect the dots here. And we basically end up with the graph of x equals y squared. All right, and the last thing that we need to do is just give this graph direction. Okay, we give this graph direction, and that's going to be right. The direction is where t is increasing, right? T is increasing down this way, which as you go down, or as you increase your t, it's going to go this way. All right, so you're going to get your direction here. Okay, like, because I guess you could say from 2 to 3, right? We're going from this point right here to this point right here. Okay, this is our t equals 2 point, and this is our t equals 3 point. All right, so you see there, right, we're increasing t's as we go along the curve that way. Okay. Next, what if we want to graph this polar equation here, r equals 2 sine of 2 theta? Well, here the first thing we need to do, right, we view r and theta as if they were Cartesian coordinates. Okay, so we put an r on the y-axis and a theta on the x-axis. Okay, the next thing that we need to do, we figure out the max and the min, so we know kind of like what our scale is going to be on for our r here. Okay, what's going to be our max for this? Well, we have 2 and a trig function. The trig function goes from -1 to 1. Okay, so we'll end up with a 2 and -2. The -2 happens when sine of 2 theta becomes -1, and the 2 happens when sine of 2 theta becomes 1. So next, we need to figure out our subintervals on the theta axis, okay? And this is where 2 sine of 2 theta is going to become a max, okay? Because that's going to be the next step, right? 0 is going to come up to this point right here, okay? Because this is, of course, a sinusoidal graph. So where would this become a max? Well, that would be where 2 theta equals pi over 2, right? Because sine of pi over 2, that's 1, right? So 2 theta, you set that equal to pi over 2, and you get that theta equals pi over 4 when you divide by 2 on both sides. So that means that our next little piece here is going to be pi over 4. You keep going, that's going to become pi over 2, 3 pi over 4, and pi, right? So, you know, and so on and so forth. You can go to 2 pi if you want, but you don't have to, because you kind of can already understand what's going on with this graph. All right, you're going to get something that looks like that. Okay, now we can do this on a polar graph. Okay, we do this on our polar graph. And by the way, some people like to draw the, like, you know, the, looks like the XY plane, right, with your X and your Y axes, but this is still going to be your polar axis. All right, it kind of just helps graph polar a little bit more to have a little more structure with both the axes there. So it's up to you. Now, what would this graph look like? Well, we're going from 0 to pi over 4, and we are starting off increasing a lot and then leveling off. Okay, so that's going to look like, right, we're starting off increasing r a lot, and then we level off. Okay, and then we come back when we go from pi over 4 to pi over 2. So that's going to look like this. Okay, next we're going from pi over 2 to 3 pi over 4. So that's from pi over 2, right, to 3 pi over 4 is over here. But it's in the negatives. Okay, so what that means is that we're going to be going this way instead. And you can kind of see a pattern here, right? We're getting that little four-leafed rows. And we can kind of just complete this here. Okay, and that is the graph of r equals 2 sine of 2 theta. Alright, so yeah, that's about it. Okay, graphing parametric and polar, parametric is very straightforward. Polar, it takes a little more practice, okay, and like I said in the last video, you really want to make sure that you are pretty concrete with just graphing polar, because that's going to help you out not only with the integrals and arc lengths for the parametric and polar tests that you're going to have, but it's also going to help you for calculus 3 because there's a lot of like polar stuff in there anyway. So yeah, that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar in the next video in the series. See you soon.